Okay, so the learning objective here is to know the formulae of circumference of a circle, area of a circle, to calculate the perimeter of 2D shapes including circles, areas of circles and composite shapes, surface areas and volumes of spheres, pyramids, cones, and composite solids. This might end up being a bit of a longer video just in terms of, because there's quite a few of these formulae to cover, but yeah, let's get on with it. So if we have a circle, let me actually use the circle tool here instead of using my poorly drawn circle. Okay, that is okay. Here we are. So we've got a circle here, and if we're looking at the circumference, that's kind of analogous to the perimeter of a shape, just kind of the length of the edge around here, so the kind of the black line. And if we have the center of the shape over here, I think we might have talked about this before, but this is the radius of the circle. So you measure, it's basically kind of the length from the center to the edge of the circle, so it can be measured from any point, and by kind of very definition of a circle, it's equal no matter where you measure it. So of course this radius is equal to this radius, right? So this is the radius, and if we extend this line from one edge to another and passing through the center, we can get the diameter, which we label as d, of course, and then the radius as r. And if we're looking for the circumference, there's this kind of value we know, it's called pi, which looks like this. This is equal to pi, pi, not PIE like pi, it's just pi. And all pi says is pi is the ratio of the circumference of a circle to the diameter. So pi is equal to the ratio of the circumference, which is c, let's say that, divided by d. So this is kind of how we know what pi is, and we've seen that with every circle that this ratio of pi is constant. And because pi is just some number, it's 3.14 da, and it kind of continues on till infinity. There's loads of cool things about it, but all you need to know kind of at this point is that it literally tells you the ratio of between the circumference and the diameter. So by rearranging, we can get that c is equal to pi d. And again, if you're looking for pi is, go on your calculator and there's a pi button. If I can find it, it's been a while since I've had to use pi for some reason. Where are you, pi? It's on my calculator. It's down here. I press shift and that, and I get pi, which comes out to 3.14 da da da. But just have a look at your calculator. It's there. And we also know that d is equal to 2r, just because you can tell this from the diagram here, of course, because it goes to the center, from edge to center, and then edge to center again, so that's 2r. So we also have that circumference is equal to 2 pi r. These are of course equivalent, and that's what the circumference of a circle is. The area of a circle is pi r squared. Pi r squared. Again, pi is this thing here, and then we got r squared. There's a few kind of intuitive ways of understanding the area. I'll link something like that in the description so you can kind of see. If you're interested in the proof, of course, you don't really need to know it. If you want, you can just memorize this and you'll kind of be on your way. And in all honesty, I actually didn't learn kind of the the intuitive reasoning behind this and a simple proof behind it until a lot later. But if you're interested in this kind of stuff, there's quite it's a fairly easy to understand proof, which I've linked in the description, so do check that out. So that's the area of a circle, and that's just something I guess you need to know. So that's this is done, that's done. Now we have to calculate the perimeter of 2D shapes, including circles and composite shapes. So what I'll do now is we'll talk through some worked examples. So this is our first worked example. This is actually on the trickier side when it comes to questions like these. But yeah, let's give this a go. So the question is asking us, so the diagram shows the plan of a field. The farmer sells the field for £3 per square meter. And how much money should the farmer get? So clearly here what we need to do is calculate the area of the field and then just multiply by £3 to get how much money the farmer should get. So the first step we need to do is find the area of the field. And when it comes to questions like these, what you need to do is to break it up into shapes that you can deal with, I guess. And there's always loads of different ways to break up the shape. You could, for example, in this one you could break it up like this here, and then here like this, and another one here for fun, or in the triangle here, and da da da. So there's I guess there's a ridiculous number of ways of breaking up the shape. What you want to do is break it up in the way so that you have the least amount of shapes and kind of the easiest to calculate the area in that sense. In this case, what might be obvious to you is that if you draw a line like this, now you've got a rectangle and a triangle, which is two fairly easy areas to calculate. So what I do is then I say, because now we've got this, I'd say something like area of rectangle. If I'm usually feeling lazy, so I just write rectangle, draw the shape and write rectangle, is equal to 100 times 75, which is equal to 7500. I won't bother with the units right now, you need them at the end. Area of triangle is equal to, well, half base times height. Well, this is 30, and this whole length, this whole thing is 100, right? Because we know that this is 100, so this must be 100. And this is 30, this must be 70. And again, applying the same logic, this whole thing is 160. Up to here, from here to here, this is 75. This must be 160 minus 75, which is 160 minus 75, 85. So you do half base times height, so half times by 85 times by 70, which gives you 0.5 times 70 times 85, 2975. So total area is equal to 7,500 plus 2,975, which comes out to 10,470. So 10,475 square meters squared, and therefore the formula should be paid 10,475 times by 3, which is equal to 3,425 pounds. There we go. We've got another question as well, which uses this composite shape stuff. Ooh, that is big. Okay, so that's a bit smaller now. Okay, so shape A is a semicircle with radius 12 centimeters. B is a circle. Nice. The area of shape A is 8 times the area of shape B. Show that the radius of shape B is 3 centimeters. So this is a show that question, and basically they've given us the answer. So in question with show that, it's basically you're working towards the answer here. So you're working towards to find the radius of shape B. But because they've kind of given us the answer already, which you might say, oh, how nice of them. It also means that it's easy to kind of fudge the working. Sometimes you can kind of reverse engineering and that kind of stuff. So what it's super important to show that question is to have very detailed lines of reasoning and kind of ensuring your layout is incredibly good. Really important with these kinds of questions. So we know shape A has a radius of 12 centimeters, and the area of shape A is 8 times the area of shape B. So let's find out what the area of shape A is. A of shape A, so is equal to, well, it's half. It's a semicircle, right? So it's going to be half the area if it was a circle, right? So the area of a circle is pi r squared. So pi times by 12 squared, pi r squared. But we divide that by 2, which comes out to, what is that? 12 squared divided by 2. And when you have pi, most of the time you leave it in terms of pi and work with multiples of pi, as we've talked about in a video way back when. So just say that's 72 pi. We know the area of shape A is equal to 8 times of B. So A of shape A is equal to 8 times A of shape B. So 72 pi is equal to, I'll say, 8b. So you can say up here, let the area of shape B equals B. So 72 pi is equal to 8b. So b is equal to, if we divide both sides by 8, 9 pi. And we can say let the radius of shape B R. We know area of shape B is equal to pi r squared, which is equal to 9 pi. Divide both sides by pi. So see, this was the benefit of working in pi, you just divide by it now. So r squared is equal to 3, therefore r is 3, and bish bash bosh, we've got our answer. So again, very important to make sure our working is correct and kind of systematic in this kind of thing. But in general, when we're dealing with kind of composite stuff or stuff that's broken off, we just think about kind of the original shape. We somehow get it to the original shape and work our way to the composite shape. So in this case, you know, we have to draw the full circle. That's half decent, full circle, and then we say, oh, it's going to be half the area because we know it's a semicircle. Here, in this one, we kind of draw a line to break it down into shape, but effectively you just have to kind of go back to the formula you do know and then work from there. Now, let's go back to this stuff here. So we've done perimeters of 2D shapes, we've talked about that. And so perimeter, so we haven't necessarily talked about that explicitly. You know, if we were being asked to find the perimeter here, so let's kind of work through that. Let me get rid of the thing here. So if we were asked to find the perimeter of this shape, you know, it's fairly straightforward in that we just have to add up the area, the lengths of the sides. So in this case, we're forced to find the length of this side here, so of this triangle. So if we remember, this was 70, this was 85. So this length here is square root of 85 squared plus 70 squared by Pythagoras, which is 5 root of 485. And then we just add these together and we find the perimeter. Then, you know, we add this, 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 and this. So perimeter is equal to 70. See, that's the issue with circling. What was that? 75, isn't it? P is equal to 75 plus 100 plus 160 plus. Also, a quick thing to remind is sometimes when you kind of label it the 85 here, you might double count. So try avoiding, you know, don't really do that. So 160 plus 5 root 485 plus 30, which comes out to 70 plus 100 plus 160 plus 5 root 485 plus 30, which is 470.11 da-da-da-da. So I'll just round that to 1 dp. And don't forget unit cm. Okay, so yeah, we talk about, you know, perimeters of 2D shapes, including surface area and composite shapes, surface area and volume of spheres, pyramids, cones, and composite solids. I'm going to gloss through these fairly quickly. So these are just formula you should memorize, I think. So yeah, if we talk about the volume of a sphere, we know what a sphere looks like. I'm not going to draw it out and waste time doing that. But so if we say sphere volume, actually, you know, it will be so much quicker if I type this out. Sphere and volume and surface area. So for a sphere, the volume is 4 over 3 pi r cubed. You know, to be honest, I don't have a handy trick about remembering this. Besides that, you know, we know, for example, with the circumference, it's just, you know, 2 pi r. So r is to the power 1. With area, it's pi r squared. So, you know, it's 2. And volume, you know, is pi r cubed. So again, if you think about kind of volume, that's 3 dimensions. So it's r cubed. That's the only way I can remember that. The rest of it is just, you know, you have to memorize 4 over 3 pi r cubed. Surface area. So again, because it's an area, we'll have r squared here, but it's 4 pi r squared. And there you go, that's for the sphere, the job done. Cylinder, I'm just going to write V and SA. So the volume is pi r squared h. I'm actually going to talk a bit about intuitively where this comes from. So in general, when we're dealing with volume of an object, if it's got a constant cross-sectional area, and cross-sectional areas is, you know, if you take the shape and you chop it somewhere, you know, that's the cross-section. So if you take the cylinder and you chop it and you take like a thin slice out of it, you'll get that circle, and that circle is constant throughout, right? What you can say is then is with that cross-sectional area, if that's constant throughout, you know that the area of the volume will equal to the area of the cross-sectional area. So, you know, I'll just say cross-section, so CS A, say that cross-sectional area times by the length. So the area of this cross-section, which is a circle, times by the length. So if you think about it, kind of that it's that disk so many times, right? You know, the area here again, 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 and you can think of it as happening, you know, for however so many times, and kind of if you think about it, if you keep adding them, there's going to be kind of like not necessarily L of them, but it's like the length ends up to L. Not the best explanation, but I hope you can see what I'm saying. So you find the cross-sectional area, which is pi r squared. So sorry, we say that's h, actually the height. So we have pi r squared, and then we just, that's cross-sectional area, and then we just times it by this length here, so times by h. That's how we get that. For volume, well, sorry, not for volume, for surface area, well, that just all the area of all the faces. So the area of this top face of that circle is going to be pi r squared. That's at 2 points, the bottom and the top. So you have 2 pi r squared. And then we look at the area for the curved surface of the cone. In that case, you know, if we think about having the circumference here, and then it's kind of their h times. So we can do, you know, then 2 pi r h, and that's that. Now we have a cone. So volume for a cone is, if I ought to draw it out, cone, because okay, so cone, there's a circle at the bottom, so that's the radius, there's the height, and then there's this thing out here, L, which is kind of, if you look at the kind of base of the cone to the tippy top, and then it's like that, whereas height is kind of perpendicular distance, like that's perpendicular up, whereas this is what we call L here, which is kind of this length, kind of along that way. So for a cone, the volume is a third pi r squared h, and sorry, that's in the wrong place, isn't it? Okay, yeah, that's good enough for me. And then surface area. So the formula for the curved surface area is kind of, which is, you know, not the circle at the bottom, but the thing around it, is pi rl. So radius times by pi times by the length here. So that's the kind of the curved thing here. So if you kind of, I guess, unwrap that piece of paper, that's that curved thing, and then you have to add the kind of the what's called the surface, the area of the face at the bottom, i.e. the circle. So you get the curved surface area of the cone, which is pi rl, plus the bottom thing, which is pi r squared. Here we go. That's a cone done, and now we are left with a pyramid. So we can have a square base pyramid, we can have a, you know, however so many base pyramid, right? But in general, for a pyramid, it's a third volume. Sorry, is a third pi. Oh, not pi. Where'd pi come from? Pi is really a circle thing, isn't it? V is equal to third length times width times height. So we have a pyramid. I'll try drawing one fairly quickly. So we have like a pyramid, square base pyramid. Oh god, that's badly drawn. But that is so badly drawn. Oh gosh. Okay. So that's a bit better drawn, I think you can say that. So we have length, width, and the height, like that. And for surface area, that kind of depends on the type of pyramid it is. So if it's a square-based pyramid, you know, we add up the areas of the 4 triangles and then the square at the bottom. But if it was a tetrahedron, of course, it'd be a bit different. So in this case, depending on the pyramid, what you should do is kind of look at the area of each face and just add them up, which is, I guess, you know, how you should approach the area of whatever shape there is. So just kind of break it down to each face and then add up the areas. So that is that. We've, as I said, blasted through the area and volume of these. Now we're going to talk about composite solids. So let's just go to some questions which have yet to be dragged in. So just give me a second. Okay, so we've got this one. The diagram shows a prism. Work out the volume of the prism. Okay, There's a few ways to go about this. You can of course split this into two cuboids and volume of each of them. But we're going to use the trick I talked about earlier about, because we have a constant cross-sectional area, and then what we just do is find the area of the cross-section and then times by the length. So let's find the area of this thing over here. There's a few ways to do this. Again, to find the area of this cross-section, I'm going to kind of do the quick and easy way. So this rectangle here is going to be 6 cm because it's 3 by 2. And this here is, this is going to be 2 cm by 1, so that's 2. If that wasn't clear, let me kind of draw it out, and I'll kind of say what I've done a bit more explicitly. So we've got this as being 4 cm, this is 3, this is 2, this is 2, this is 1. So we have this rectangle here on the left, that's 3 centimeters, that's 2 centimeters, so this is 6. This is 2 centimeters, this is 1, so that's 2. So the area of cross-section, A of cross-section, is equal to 8 cm. Therefore, volume is equal to 8 times by the length, which is 12. 8 times 12, what is that? Can I do that in my head? What is that? 80 plus 16, so 96. 96 what? Centimeters squared. Need the units. And that's kind of it. With questions like these, when we have constant cross-sectional area, just the way you approach it is find the area of the cross-section times by length. If you're struggling, maybe the cross-section area is not constant, which it does happen in certain situations, what you need to do is kind of break the question down into two parts, and kind of find the volume of one object that you can do because you already know it, and the volume of another. The kind of the cheekiest ones when it actually comes to these kinds of questions, I think, are is if we have a cone. Such as this, right? And what they do is ask us to find let's say actually that the top of the cone is kind of chopped off, and you have to find this volume of this thing over here. And so the way to do this is, what they often do is they'll give you this radius here, and give you this radius here. So I'll call this big R and small, big R and small r. So what you do is you want to find the area that I've shaded in. You find the area of the full cone, because that's a formula you know, and then you find the area of this little cone, and you do the big cone minus the small cone. So A of shaded is equal to A of big cone minus A of small cone. And so what, usually it's adding things together, adding volumes together in terms of composite shapes. Sometimes you have to subtract them, so watch out for that as well. We've got another question as well, if I can find it. Here we are. Okay. So, the diagram shows a prism of length 90 centimeters. The cross-section PQRST is a semicircle above a rectangle. The PQRST is a rectangle. RST is a semicircle with diameter RT. PQ is equal to RT, which equals 60 centimeters. PQ, and you can actually see all this information is represented in the diagram. Calculate the volume of the prism, answer to 3SF, and state your units of the answer. Very important here. They've actually specified that. Two different ways actually to go about this. Find the volume of the cuboid, and then this semi-cylinder, I guess. But we're going to use the trick I talked about earlier by finding the area of the cross-section and then timesing it by the length. So, area of the cross-section, okay, so, area of this rectangle here is just 60 times 45, so, what is that, 60 times 45? 2,700. And then area of the semicircle, A of semicircle, what's that going to be? It's equal to area of the circle divided by 2, right? Which is half pi r squared. Half and pi, and r is, this whole thing is 60, which is the diameter as it says in the question, or t. Then the radius must be 30, right? By 30 squared, which is, what is that, 900 pi, no, 450 pi. And again, tend to leave it in terms of pi until we have to evaluate the final answer. Just check that on my calculator, yeah, 450. And now, so we have area of cross-section. Again, if you were doing this, please write out cross-section in full. I'm just doing it to avoid, to rewrite cross-section. But just in terms of, CS isn't a very common short form for cross-section. Let's just write cross-section out just to be safe. Is equal to 450 pi plus 2700. Therefore, volume is equal to 450 pi plus 2700 all times by 90, which is equal to, if we pop this on our calculator, a very large number, 370234.5025, and then I assume it carries on actually. And now we need a 3SF. So 1, 2, 3, that's the 3SF. So 370, and then these will all become 0. So 0, 0, 0, and it's just centimeter cubed in terms of the units. I don't really imagine there's any world where you'd convert this into meter cubed, even though it's a fairly large number, because that just adds an extra layer which you might get wrong. And it's also you to set your own units, and it's perfectly reasonable because they've given you centimeters to just do it in centimeter cubed. So I actually advise you not to convert into meters cubed in case you get it wrong. There's no extra marks for kind of doing that conversion, so there's no point in you going ahead and doing it. Just leave it in centimeters cubed. This was actually our last rote example on this topic. So yeah, hopefully that all made sense in this video. But basically, we talked about the basic formulae, and those you'll basically have to memorize. I can't lie. I mean, it's just helpful to memorize them, and even sometimes it's not even like if you got them memorized, you don't even have to waste time if they're in the formula book to even going back to the formula book and looking at them, wasting time like that. Just if you just memorize, it's quick and easy to use. And when it comes to composite shape, just break it down to stuff and use this cross-sectional area times by length trick to find the volume. But yeah, hopefully that all made sense, and I'll see you guys in the next video.